Hello, and welcome back to the Raw Code Academy. You may remember recently we did a video on Scribe Security. They offer a platform that allows you to collect evidence, visualize that evidence, and understand the supply chain of your software. What we didn't cover in that video is that Scribe Security's platform also has a command line application called Valint. And we're going to take a look at using Valint today to collect that evidence and store it. Not only that, we're going to take a look at enforcing policies to make sure that your software and supply chain are up to scratch. So let's take a quick look at the Scribe Security documentation for Valint. Okay, here we have the documentation. As I said, Valint is a command line application. Why is this interesting? Well, it means you can run everything you're about to see locally, just as I am running it locally on my machine. Not only that, because it's just a command line application, you can run it in your CI/CD pipeline. You want to run Valint in GitHub Actions? Go for it. Valint can even be run as an admission controller within a Kubernetes cluster, allowing you to enforce policies that verify your supply chain at runtime in production. So how do we get started? Well, the documentation has two ways to get access to Valint. Number one, curl and pipe to your shell. You can grab it from get.scribesecurity.com/install.sh, where if you put that through a shell, you will get your Valint in your local directory. Or you can pull the Valint container image from their JFrog instance, which is scribe-security.jfrog.io/scribe-docker-public-local/Valint latest. Of course, all of this will be in the documentation and we'll make links to it in the show notes below. So you don't have to listen to me read out slashes, dashes, and all sorts in between. However, get yourself access to Valint and you can follow along with this tutorial. So as I said, Valint allows you to collect evidence to help you build out supply chain security posture. That evidence can come from Python or from PyPy, as we can see on the support table here. It also comes from NPM, from Go, from Docker, from Red Hat, Java, Debian, and so forth. Hopefully that covers a good portion of the landscape of the runtimes and programming languages that you're using and the operating systems or technologies you use to deploy. As far as evidence goes, of course, we have access to NIST, SigStore, CVEs, etc. And the really cool thing about what we're going to show with Valint today is that you don't need to push that evidence to Scribe Security, although you should with that very generous free tier we covered in a previous video. But you can actually store that evidence inside of an OCI artifact itself. And we'll be doing that on today's tutorial. And again, because it's a command line application and there are GitHub Actions available, you can run this on GitHub Actions as part of your CI/CD process. Okay, so why don't we generate a bill of materials for a container image? What do I mean by that? Well, we want to start collecting some evidence. We want to pull down an image, understand how it's built, and generate that bill of materials. And we can do that with Valint. So step one is obviously just make sure you've downloaded and have access to the Valint command line. Once you do, you have access to the Valint BOM command. We can type help on that. There's a whole bunch of options to help you start collecting all of your evidence. So let's do Valint BOM. Now you get to choose the output format that you wish to store it. I'm going to do a test SLSA, although we'll cover more options in just a moment. Lastly, provide a container image that you want to collect and store the evidence for. For me, let's do Alpine latest. This pulls down the image and then we'll give you a prompt to ensure that you're happy to publish the evidence to the transparency log. Let's hit yes, and this will ask me to log in with SigStore. And done. All right, so let's go through this in just a little bit more detail. First, we have said that we want to generate a bill of materials for Alpine latest. We see here that Valint will actually pull down the image from the remote registry. In this case, that is Docker Hub. We can also see that it collected some context, which is type local. And that's just because I'm running the command line application locally on my own machine. Valint has knowledge and awareness of other contexts, such as GitHub, GitLab, and so forth. And we'll see a list of them in a moment when we head back to the documentation. Then you'll see we get a little bit of a pop-up asking us to confirm that we're happy for some information to be stored in the transparency log. So why did this happen? Because we did an -o, a test SLSA, the default attestation is with SigStore. If we run valint --help and scroll up to here, you'll see that --attest default supports X509, Sigstore GitHub, or Sigstore, with Sigstore being the default. That just means that our information will be published to the public transparency log and signed with Sigstore. Once that's all done, we're now in a position where we can actually take a look and verify the information that we generated. And that verification step includes any policies that we define. So let's run valint verify, and we set the input format, which will be the same as the output format we used earlier. We can then say that we want to verify the bill of materials for the Alpine latest image. As we can see, this pulled this down from the public record, and we have a cache stored in our local directory, and it also verifies the certificate authority that signed this information. As you can see, we already have a policy called raw code only applied, which passed, and we'll take a look at that in just a moment too. So let's talk about that environment context. When I ran it on my local machine, the context was local. Why? Well, because I ran the command on my own personal machine. However, when you're generating your bill of materials, it's more likely that this will run in an automated environment, such as your CI/CD pipeline. As you can see here from this list, that Valint supports and understands various contexts. It's likely you're probably using GitHub Actions, as that's where a lot of open source and even proprietary software development happens these days. Of course, GitLab, Azure, Bitbucket, and so forth are all very popular options and also provide their own CI/CD environments. When you build your bill of materials, you want to suck up as much information from that environment as possible, like the branch name, the repository name, the committers, the tags, and so forth. And if we scroll down, you'll actually see that as part of this environmental awareness, Valint collects the URL, the branch, the commit, the tag, even the workflow names and the actors and the build number. So collecting this information just means that you can build policies to ensure that your production cluster only ever runs workloads where you can prove through evidence collection that the build happened on your CI/CD system and signed with the keys that you expect. So now let's talk about that policy. So we can you should definitely have a policy that ensures your proprietary software only runs if it was built in your CI/CD pipeline. However, you can get started with policies much, much easier. Inside this directory, I have a valint.yaml. Inside of this, I have an attestation cosign policy. This just means a cosign policy, where I have raw code only. And we already seen this name run when I ran the valint verify. We have the enabled true flag just to make sure this policy is enforced or checked when we run valint verify. And then we can add one or more modules to run as part of the policy. Here, I have a module named raw code module, where the type is to verify the artifact. We enable this, and what we're saying is this artifact must be signed, it must be in the format attest SLSA, and the signer identity must be one of these people, and in my case, I'm using myself, which is david@rawcode.academy. So let's change this policy and break it. Let's say I use rawcode.com, and now we run valint verify -i test SLSA Alpine latest. Again, this is going to check the evidence creation within the public record, pull it down to my machine, and then our policy runs against the collected evidence. As you can see here, the signature for this evidence was not me, or at least was not david@rawcode.com. This time it goes, hey, actually, this is signed by david@rawcode.academy. So you can see how powerful this would be if your CI/CD system is configured to sign something. You don't want another workload not signed by that identity running in your cluster. So let's understand evidence collection in a little bit more detail by diving into the output itself. Let's run Valint BOM again with the attest SLSA output format. This time we're going to set the output directory to be evidence, and again we'll run this against Alpine latest. This is going to make sure we have the latest version of the image, collect all the evidence, ask me to sign it once more, which we can do here. And then it will store all of the evidence it collected into the evidence directory. As you can see here, we have a cache.json. And if we just cat this and throw it through JQ, we can see that local context and the information that it collected. This is the information that you can use to build and enforce your policies. If you do this in GitHub, the context will contain all that extra information, such as the branch, the URL, the tags, and so forth. But locally, we have access to my hostname on my machine, the user that built it, the time, the inputs, and then the subject context, all there and available for you to introspect. So far we've worked with container images, publishing the evidence to the public record, and storing information in cache locally. But what if we want to keep that somewhere that is a bit more transparent and visible to our organization, our clients, our customers, and so forth? So let's do a Valint BOM test SLSA. Only this time, we'll scan a Git repository. Mongo express mongo express.git. Now I've already ran this and the cache is already available locally. So we got a cache hit and it didn't need to do it again. Sweet. However, that cache still lives on my local machine. So let's push it and store it inside of an OCI artifact. So this time we'll run Valint BOM, a test SLSA, and we're going to scan my GHCR raw code clustered v2 image and enable the OCI store. And make sure you spell SLSA correctly. So much like all the other commands, this is pulling down an image, collecting the evidence. However, this time it's going to store the evidence remotely on the OCI registry, next to where the container image actually lives. And it's done. You trust me, right? Let's head over to GHCR, where we can click on Packages, Clustered, and here we go. My v2 image was built a year ago. However, less than a minute ago, we published our attestation to the OCI registry. This can now be pulled, inspected, and verified again by my team, my organization, my suppliers, my customers, and so forth. Awesome. So one last thing. So far, all we've really covered is SLSA attestation, which gives us confidence or a record of where things were built, how they were built, and when they were built. But Valint supports all of those runtimes and languages that we covered on the graph at the start. So let's take a look at building a bill of materials for a Go project. And let's keep this topical. I'm in a directory taking a look at Blue Sky Go SDK or program called Indigo. From here, we can run Valint BOM, where we specify that we want to run this against the current working directory. This has already been run, so it was pretty fast, and we can see that the analysis has already been completed. And the output has been stored in the generic Valint cache. Let's run this one more time. And just to make things a bit easier for ourselves, we'll set the output directory to BOM. Now we can go inside the BOM directory, where we see we have our cache.json, much like we had with the SLSA attestation. We can cat this and pipe it through JQ. But we also have this other file, which is the complete bill of materials. Now when you do attest SLSA, this is a encrypted payload. However, without attest SLSA, we have all of the information in the bill of materials available. Let's do this one more time, but put it through a pager. Here we can see that the default output format is CycloneDX. We can see the components involved as part of this bill of materials, including the Git repository and so forth. However, what's really cool is when we scroll down, we get into all the dependencies. Because Valint understands Go, it understands Python, it understands Node and NPM. We get a complete bill of materials, including all of their dependencies, the versions, and where they came from as part of our bill of materials. So there you have it. Valint is a pretty sweet command line application that you can run locally in CI or even as a mission controller with Kubernetes. It allows you to build attestation for SLSA and Cyclone and a bill of materials in various formats, hooking into various runtimes, programming languages, and even contexts such as local, GitHub, GitLab, and so forth. So go check it out. Improve your supply chain posture today. Go have some fun.